Welcome to the June 10th webinar series between Opto 22 and Inductive Automation Australia. Today's webinar is titled Opto 22 in Australia, Then and Now. It's meant to show how our history in Australia. So today, joining us today is Ed Fuentes from Inductive Automation Australia, and having a little bit of technical issues with Ivor at Binford Tech. He also should be joining us here shortly. Ed, would you care to introduce yourself?
Yeah, hello, Renee, and everyone else online. Well, I'm sorry, Renee, quickly, I don't seem to see my image. Am I coming through as well on the screen? I'm assuming I am. Anyway, everyone, welcome to this second webinar with Opto 22. We are having a great time. Our last webinar, we sort of talked about the benefits of that hardware and software mix, I think, here, Renee, and how it actually helps in the IIoT and digital transformation journey that a lot of our customers are experiencing. Some are more advanced, some are getting there, but I think this integration where hardware and software come together to provide interesting solutions does play right into the hands of many of those customers looking at how they move in this space. And something I'm very passionate about is watching companies, especially here in Australia, move from Industry 3 to Industry 4 and the technology that helps them get there. So thanks for letting me be part of the webinar today, Renee.
Couldn't do it without you. Thank you for being here today. And Ivor Houston with Binford Tech. Get to see that you've figured out the technical issues. Glad to have you on. And
I made it.
Right in time to introduce yourself.
Yeah, hi everyone. Good to be here. My name is Ivor. I'm a technical sales consultant at Binford Tech. A little bit about Binford Tech. We're a solutions-driven Industry 4.0 innovator with about 25 years of experience in FMCG, fast-moving consumer goods, and multi-segment automation. We partner with leading manufacturers and producers across Australia and the APAC region, delivering advanced automation and smart manufacturing systems. This also extends to things like smart agriculture and OEM innovation. And we do this by, utilizing edge control, cloud technology, smart devices, IoT, and next-gen automation techniques. And so, I've got a case study a bit later on in the webinar, which I'm really excited to show you guys. And I'll bring it back to Renee for now, and I'll see you guys soon.
Yeah, Ivor's part of the webinar. His case study is the most fun part. It's the modern one. It's the one that uses Ignition and Opto together. I have the before part, so we're going to show some older stuff. So what we're going to talk about today is, who we are, who is Opto 22. It's still a question we get a lot in Australia. And then a timeline of us in Australia. We've actually been there for decades. Been here for decades. And I'm going to go through just some of the key case studies, some of the key equipment that was used at that time. 90% of it still operating today. And Ivor, as we alluded to earlier, is going to talk about the case study that's using everything, that's using Opto, Ignition, and all the tools that you're familiar with as well. And we'll end that with Q&A. So we're going to go a little fast here today because this is being recorded. And Opto 22, established in 1974, hosted by founders and engineer, one of the co-inventors of the solid-state relay. And that's where it started with rugged control, IT systems. We went into, actually, I don't need to explain that because we're going to talk about the entire timeline now. In 1991, we moved to this factory, and this is all Opto 22 owned and controlled in Southern California. All of the Opto 22 products we'll talk about are all manufactured here in this building. So in 1974, we started with these solid-state relays and quickly started putting them on different circuit boards. And then using this new networking technology, new at the time, of 485. And then as the PC came on board, we started having intercommunications with more Windows machines, more PC machines. And that intercommunication was sometimes via ArcNet, as we'll see in some of these configurations. Talking already to, of course, Microsoft architectures and different types of communication, the serial and ArcNet being the key ones. Around the time I joined Opto was in the 1990s, and that's when we had serial and our first Ethernet-based products. Back then, Ethernet was seen as a huge mistake because that's meant for printers and for office buildings, not for the factory floor. but we see how that's changed. And then moving to PACs, and now 2017 with our ignition ready Opto 22 Epics and Rios. So we'll quickly go through this because this is the old stuff. We just wanted to show you these applications, and these are actual diagrams and pictures from Australian applications of, you see these 485 cards. That was Optomux in the 1970s. So we mentioned Mystic in the 1980s. Also in the 1980s, with those mixed stick controllers, we had MRTU units that had a little bit of I/O built into the control system. Were great, especially for water, wastewater applications. So that's the 80s. And moving on to the 90s, changing out just those brains. The SNAP modules got to stay exactly the same, but the brains were being able to change now from serial over to Ethernet. And then in 2004, just because you have all this capability now, putting all this compute inside inside the same units that used to be brains, you have the full control system in an architecture that looked like this towards 2004 and on. And of course, in 2017, that point we actually had products with ignition in them before the Epic and the Rio existed. We had them on separate boxes at that time. So when the Epic came out, we had ignition already on it. And of course, with these Epic and Rio systems, of which we'll talk about later, to this point, we're running 8.3 on them. We even support Ignition Edge Panel directly on the hardware, and it can be part of any type of your control ecosystem. So that's our technology being in Australia. What about what projects? Well, some of the descriptions that I'm going to give about the projects today helped me see something I didn't realize before, and that's that Opto 22 diagrams and case studies existed well before the invention of a good digital camera. So it's been really hard to source some of these. But in these projects that we're going to go through, the point of it is, in all of these different projects, not only are we in Australia, but it's the same pieces and components. It's I/O, it's remote I/O, it's controllers, and it's PC-based software that is a perpetual license. So in those are the configurations that you're going to see. So these projects include water, wastewater control in Sydney, Australia. We have a large facilities project that's been decades long over in healthcare and building management at Hamilton Island, which would be some of you recognize as a keen vacation destination, has a lot of not only building management but also water treatment systems throughout the island that are all done with Opto 22 systems. Sydney Harbour Tunnel, when it in its opening of 1992, began with Opto 22 Paymux and Optomux systems. On Perth, actually, Ed, this one, I knew about this project, but only in researching for this webinar that I found that this was in Perth. So we'll have to talk later about this to see if maybe we know those people still.
Yeah.
And on top of that, in New South Wales, we have a few more projects of shipboard controls, cogenerations and boilers for the hospitality industry. And of course, if you've ever seen the James Cameron movie with the submarine in, I believe it was 2014, Deep Sea Adventure, like that it's called, but it's a real movie. It's James Cameron movie. It's it's National Geographic, won all kinds of awards. That's a fully controlled Opto 22 system, and all of that design and manufacturing was done right outside of Sydney. So to go into a couple of those projects directly, for water treatment and for treatment systems and for water wastewater, it's the SNAP-PAC system, the ones that you saw from the 1990s and the 2004s, that's mainly used. And it's those racks in a 8-module configuration that are used to remotely connect over Ethernet, usually over spectrum radio at the time, and now upgraded, luckily, to cellular radios to do that control over in Hamilton Island. So there, you'll have the different pumping stations throughout the island, all communicating back to one central location and monitoring your typical floats, your typical pumps, your typical alarms So you can have a very efficient team that is monitoring, controlling all of the systems in there. And of course, is the SNAP-PAC systems. So that's one.
One of the key things there, Renee, is especially locations like that. And Australia's got that uniqueness that we are quite vast as a country. You know, with 28 million or so people here across the size of the continent, not too far, not too dissimilar to the US. We have lots of places that are quite remote. So having hardware, and this is something that comes up quite a bit, Renee, in discussions with customers, especially in those remote locations, is having hardware that has a long service life that can be supported for many, many years, because it's one of those applications you install and you don't touch for many, many, many years. And I think that's what Opto 22 do very well, in that they've got that track record of having products that have been installed many years ago, still supported, still maintaining current technology.
Yeah, thank you for mentioning that specifically. In all of these projects, most of 90% of them are still operating today. And in those projects, I would say about 80% of the hardware is still being manufactured today. So when you look at, like Ed mentioned, when you look at your hardware vendor, look to see what their oldest product is. Look to see what their oldest supported product is. For us, it's a product that we've had since the 70s. And you're asking, how can you support a system from the 1970s to now? Well, that's pretty easy. You see all of these solid state relays that are all manufactured by Opto 22, they carry a lifetime warranty. So the IO, the field wiring, can stay absolutely the same, but a product from the 1970s, we can replace it with one with now Opto 22, instead of removing the 485 communication, simply added an Ethernet port. So you could have the same unit and the same serial card that you had before, unmount it, mount an Ethernet card, and that's enough to be able to pull information to any Opto 22 Epic or Rio. And once you're there, now you have Ignition Edge, you can send it, transmit it, you know, do whatever you wish with that data.
Yeah,
So,
that technical debt is reduced a lot when you have a product like that, a hardware product that has the longevity that Opto 22 does have in the industry, and also not just that, but it's made by and managed by Opto 22. The outsourcing of it is still, you don't outsource it; it's within the business.
it's all our design, our manufacturing. Great point for that. Another key industry that we're in Australia is in facilities, healthcare, energy management. We'll have several campuses of healthcare centers throughout the country. One of the main ones that we work with are over in Ballarat. And in the Ballarat Hospital, you're looking at several campuses, several buildings, just about everything at that location. I've been there and I thought I could use that video and those images, but they are so grainy. If you want to see them, I'd be happy to share them, but they're honestly a little bit, just a little bit dated for this webinar. But in there, everything from the ice blocks that they use to be able to maintain temperature, the compressor systems to be able to make sure they're air-driven tools, their grinders, their drills, the temperature where there were these senior aquatics aerobics classes are being held. They're all Opto 22 controlled. The refrigeration systems of where all the food is kept, you know, that everyone depends on being of the top quality, is all there. The security systems. So it's all with Opto 22, and it's all been for several decades now. And in that, we're going to, I think here we have some images of that. Let me see. Be able to show, we showed some images of that before. Those cards are actually from images of the control panels in operation today. And even now, because of that lack of technical debt, the fact that you can now just upgrade, now we have even projects of where we're having full ignition at that location, talking to those IO points, because again, the hardware, the IO system is guaranteed for life, and we create a path for you forward. You don't have to rip and replace. That's simply not in our vocabulary. Beyond anything that care to add to that, Ed or Ivor?
Look, Ballarat is once again, it's one of those regional locations. Renee, you've been out there. It's quite a big, large regional town, and the hospital is one of the only hospitals in the area. So having it 24/7 available and running consistently is key, as you probably know, for any of these critical infrastructures like a hospital is. And the fact that it runs, and it gets quite cold in Ballarat. No, not as cold as the US, but we definitely get cold weather there. So having the extreme temperatures and be able to survive in that environment is quite good as well for the product.
For sure. Yeah.
Yeah, and looks like we had them on the webinar last time. And not, I'm sure they'll catch the recording. So hello to Ballarat from us. So, for a hospital situation, reliability, that's the number one. Not only longevity, but reliability. So the fact that Opto 22 has been used for that long tells you what you need to know about the product's longevity and capabilities. Also, like as we mentioned before, tunnels and utilities, a very, I think, is just incredibly cool project of the Sydney Harbour Tunnel. Back then, the same type of racks. Now, mind you, these are 4-channel, but 16-channel racks. Some are digital and some are analog, but they're using both Optomux and Paymux IO Opto 22 IO systems. Now, those IO systems are still there, and in 1992, Paymux and Optomux means that the interface to those IO cards, if it's Optomux, it's 485 serial communication that was daisy chained and dropped everywhere. Paymux is something different. Paymux is super high speed. You're talking microseconds, but it's parallel bus. So, of course, a different type of configurations, different type of networking. Those cards or brains are replaceable with Ethernet versions of them now, so you can now integrate them into any Opto 22 Ethernet system, and they're all in an Opto Ethernet-based controller is ignition. So wherever you have this type of traditional infrastructure, it doesn't even have to be ours, you add the Ethernet converters from Opto 22, and ignition is sitting right on top of them. So the RTUs were upgraded over time, but the field wiring stays the same. It's one of the great advantages of using Opto again. And also for energy utilities, using several of the PC cards directly in the PC to talk to electrical utilities. That's throughout Queensland. So in this, we see that tunnel, and we're now in the process of communicating and migrating them over to Epic, meaning that field wiring stays the same. The Ethernet card stays the same. Now we're just adding that edge device, that edge layer, where ignition edge or full ignition can reside directly in those panels. I'm sure we've all driven through that tunnel. Everyone here.
So I was.
Yeah. So then lastly, we'll go into marine and subsea systems. This is not only the shipboard geotechnical drilling that we mentioned over in Perth, but also, like you mentioned, the James Cameron submarine. And for those systems, for remote drilling, Opto 22 does a lot of offshore systems, not only with of course, the Epic and Rios that we provide now, but also with the older SNAP-PAC systems. I remember quoting those numerous times. We even had a 19-inch rack mount configuration system. So all of these what am I trying to say? The shipboard systems, just the offshore, that's what I'm looking for. So all of these offshore locations just found a 19-inch rack, found the Opto in it, had the communication port through Ethernet, and we're typically communicating via SNMP back to one central location. And through these, we get asked a lot, actually, for a lot of marine certifications. The Opto 22 can't be certified specifically for that marine capabilities, but we do have several applications in marine that have the marine black boxes. I don't know if they're called the same things for airplanes or for ships, but it's the ship black box that's all Opto 22 controlled, that's doing all the data gathering, and that system has all been achieved that shipboard approval. Similarly, on top of aircraft carriers, this is not Epic or Rio, because this was designed in decades ago. This was with the SNAP system. If you're looking at what's EMALS, the EMALS project, another shipboard application, where it's Opto 22 that's being used to launch airplanes off of aircraft carriers. So they're being launched now using the Opto 22 system as a driver for their railgun, as opposed to the hydraulic systems that are so much heavier and so much more complexity to them than what they have now. So with that submarine, full Opto 22 control, watch the movie, you'll see James Cameron with an Opto 22 logo right by his forehead for about an hour and a half there. And that was Opto 22 that helped bring that to them.
Yeah. That went down to like, what was it, 11 kilometers in the Mariana Trench? That's pretty cool to say. The epic's been all the way down there.
It has been.
Ocean's deepest point. That's pretty impressive.
Well, we've checked it out and and made the movie.
Yeah.
So in there, we go to transitioning to today, and it's a good transition to start looking at what Opto 22 projects are now in Australia. Just wanted to show you that, we've been here. We've put the equipment in remote areas. We've completed projects that you're likely working on the new generations of, and it's the same product pieces. It's the same Lego blocks that now for the Epic, like you'll see here, it's modules, power supply, CPU, and a rack. Just in a different form factor was the Snap line before, but now with Opto 22, with any of the new Epic or Rios, any of this hardware that's out there, you quickly have a way to just bring Ignition Edge directly on top of it. And that's not only Opto, but that's a Rockwell system, that's a Schneider system, that's a Siemens system, with the Epic just sitting on top, being your Ignition Edge and publishing that up to the cloud or to your on-prem gateway.
I think what you're showing too, Renee, is that probably the evolution around how you've probably Opto's been a bit of ahead of the curve, in that you brought Ethernet out quite early. You have the ability to have these high robust the PAC system with plugging in different modules, being flexible on how you deliver solutions. And I think that's what has won the Opto around those sort of use cases, which a traditional system wouldn't do. You have to have a product that is robust, resilient. And then now you've actually moved to the next evolution, where you're now not just having a hardware platform, but you're ingraining it now with software to drive the integration of software and control right there at the edge, right? That's where the action is happening. And I think that's where Opto 22 deliver. They've got that sort of background where you've provided solutions that are very little technical debt, so that you've got a platform that you can load, that runs robust, has the modules, as you mentioned, and now you run software at that location, maintaining the resilience that the Opto 22 platform delivers. So I think that's a really good understanding of where we are today.
Great. And you bring up a good point that every now and then, it feels like every couple of months, we'll get a call that a systems integrator stumbled on this PAMUX system from Opto 22, but they can't find it online. And honestly, some of those we've converted into very large sales, because let's say the entire factory is running on an old Opto 22 PAMUX system. A systems integrator finds it, calls me, finds out that they don't have to redo the wiring, they don't have to redo the IO is guaranteed for life, that if they want to recertify and re-guarantee everything for the next 3 years, all they need to do is change the backplanes, the power supplies, and now instead of the 50-pin ribbon parallel bus card, they buy an Ethernet card, Ethernet circuit card that goes on top, and they can use an Opto 22 system. In one of those cases, the controller, all of the control systems were all Rockwell controlled. So in it, the systems integrator said, no, I have a Rockwell system, I have the Rockwell PLCs, but I want to continue using this IO because it's already there. All we did was sold them dozens and almost hundreds of cards for them to convert all of those to then Ethernet IP, and Ethernet IP up to even an entirely different control system. In the end, in our core, in our soul, we're an IO company. Now, all of these incredible tools that we have, our engineers have great capacity of implementing, everything from MQTT to a couple really new great things on our roadmap that we'll be sharing in the next few months. We're really ahead of the curve on it, but at the end of the day, we know that you're going to have to wire, let's say, an electrical system, which is a good transition to here to this to our modern architectures of what Epic and Rio are. So with a Rio, you can put a Rio of any type, and a Rio is a remote I/O. It's got I/O inside. It's got CPU capabilities. It's got Ignition Edge already inside if you want to use it as well, to send that communication MQTT back to one location. So you have that just native MQTT is here as well. So let's say if you have tens of thousands of these somewhere, they're all publishing to one Epic, and that Epic will have Ignition Edge, and there are several hundreds of those Ignition Edge that are then publishing up to a cloud. That's architecture now. Or to simplify it, this is what a single location is, and this is going to look a little bit like what Ivor is going to be talking about here shortly, just one single location. But if you use Ignition Edge, now you've set up the crux of what your SCADA system is going to be. Now you just copy paste that as you add different factory lines or even different physical locations. So with the one unit, with the one Epic, with the one Rio running Ignition Edge, everything below can be just like what we saw in those older Australian case studies. And now everything on top is everything that Ignition is. The MQTT, the publishing, and all the different tools for synchronizing, for creating dynamic architectures, for redundancy backups, to trends, etc. And here we see a couple of those customers that are using that architecture. They're using Opto Ignition Edge because they can create that one skid that they can just print and copy paste. And whenever they're activated, they're publishing and announcing themselves to the SCADA. Or there are different parts of them. They're a part of just an older oil field that they're at a remote location, have Rockwell PLCs everywhere, and they want to quickly gather that information via Ignition Edge and send it back to one central location. So if there's anything to add here, this would be a good time, because otherwise next up will be Ivor with the new Australian case study.
I think you just said everything, Renee. It's everything I was going to say.
Oops, sorry.
No, it's cool. It's cool. I mean, yeah, my case study is pretty much says all of that. So that's really cool to see a real world example. Is this a good time now, Renee?
This would be perfect. So
cool.
I will stop sharing and let you take it.
I'll just share. I'll just send a request to share.
Yes.
So I suppose as Ivor gets ready there, Renee, I think in that diagram you presented and demonstrated was some of the key aspects that we find in industry that you and I probably see quite often, and Ivor too, is around the connectivity to data that's coming from disparate data sources. Like you mentioned, different PLCs, different devices. And when you start bringing this back into something like an Opto 22 and maybe using Ignition to bring context to data, but to normalize that data, that they can propagate it up the stack. And I think that's quite a clever way of how we manage data from the edge all the way to enterprise. And what I was going to talk about, I'm assuming, is the Tassel story, which I've sort of seen this happening here too. I'm quite happy to look forward to seeing this story play out.
Yeah, awesome. No, I'm really excited to show you guys. So this is a case study of a prominent Australian salmon farmer and supplier in Australia. And this is how we simplified and modernized their infrastructure and architecture. So to start off with, this is an overview of their site. So I'll just run you through quickly here. So they've got Rockwell PLCs, and these are controlling their ponds. This is where their aquaculture is. This is where the fish live. And obviously all that information goes through a Kepler server and goes to SCADA. Their generators go through Siemens, their connected devices, their VFDs, their valves, sensor data, that kind of thing goes through Ethernet to Siemens, and it all goes through Kepware. And this is what the crux of what I want to talk about is Kepware acts as a translation bottleneck between the SCADA and the systems. Now, what does that mean? What is the issue with that? What is the problem with that? The problem is it is a single and critical point of failure. So if Kepware goes down, all PLCs and SCADA cannot communicate. So the site goes completely dark. Not only that has been a problem, but they don't use MQTT. I don't actually remember what they use, but they don't use MQTT. They use a polling comms. And so what does that mean that they don't use MQTT? That means that there's wasteful polling. So even if a pond's oxygen level stays the same for 5 minutes, it's still getting polled every 100 milliseconds, every second. Right. What does that mean? Wasteful polling uses more network bandwidth and processing power. The other issue is there's just a lot of vendors going on. There's the stack is quite large, and that just means that it's fragile by design. So if there's a misconfiguration, an update issue, network issue, then there's just more things at play. It's more brittle, it's more fragile. So those are the issues that the engineers came to us with, and these is what we're kind of working with. Now, it is a brownfield site, so there are some constraints that we had to take into account. The first one being is the Rockwell PLCs. We cannot touch these Rockwell PLCs. These control the aquaculture in the ponds, the fish. This is their whole business model. If these go down, the whole business goes down. So we cannot touch the Rockwell PLCs. And the solution must be agnostic. So it must be able to work alongside the existing Rockwell layer and not replace it. So the challenge is, how do you rectify these problems and modernize them without touching the Rockwell layer that's keeping the ponds alive? And the secret sauce, the solution, is this here. This is exactly what Renee was talking about. And this is what's really exciting. This is what's really cool to show you guys. So the first one is being Groov Epic. We implemented Groov Epic into the architecture. As you know, the Groov Epic is an edge programmable industrial controller. And it's a decentralized edge controller. That is really important. And I really want to hit home in the webinar today. If there's one thing you can learn from this webinar, is it's decentralized. Okay, so the edge controller speaks every vendor's native language. There is no translation layer. There is no single point of failure. The next thing is it uses MQTT. So it's a modern lightweight messaging protocol that you guys, I'm sure, know, and it's less traffic and fresher data because it only polls to ignition when there is a change. So it's not wasting bandwidth, it's not wasting processing power, it's instantaneous. As soon as there's a change, it updates ignition with the new change, with the new tag value. And it's also got instant failure detection. So with Kepware, there was no instant failure detection. So there's no birth and death certificates. So by default, MQTT has that, whereas Kepware, it doesn't have that by default. So you might not know that a sensor or a valve or a tank is, dropped in value until you realize, and obviously, seconds or milliseconds, everything is crucial when, it's a big system like this. And they also used Ignition. So we upgraded the system with Ignition, being a modern cloud SCADA platform, it receives all their data. The other one is Ignition Edge. So this comes natively on the Groov Epic, as I'm sure you guys probably know. It's a lightweight SCADA runtime. So there's no Kepware, there's no middleware. So it comes built into the Groov Epic. And obviously it runs CodeSys. So it replaced all their Siemens PLCs, all their logic, and it's all consolidated on that one Groov Epic. So why did we go with Groov Epic? There are multiple reasons, but just to name a few, is it's vendor agnostic. So the Epic can speak to Rockwell, can speak to Siemens, and any other vendor simultaneously. So it has no allegiance to any single stack. It's brownfield ready, so it integrates alongside existing infrastructure without control layer changes. So there's no disruption, and maximum modernization. It's also got native connectivity, so it connects directly to Rockwell PLCs via Ignition Edge. So there's no translation layer, there's no middleware, there's no Kepware required. It's also a single edge device, so it replaces the two hardware stacks, so the Siemens PLCs and the Kepware server, consolidates that all into one edge unit. So before I mentioned that the Kepware has the Epic has a label that Kepware could never have. I don't know if you remember it. It's very important, and it's something I really want to hit home today. I don't know if you guys remember it. But in case it's not in your mind, it's decentralized. And this is where I get all nerdy about, because this is what excites me. It's decentralized. And the reason that is so important is because Kepware, what they had before was, if you just imagine it in this analogy, Kepware is like one bridge. All the information goes through that bridge. If that bridge goes down, the whole site goes completely dark. Now with Groov Epic, it is a decentralized system. So it has multiple bridges. So each pond is controlled by Groov Epic. So if one pond goes down, that Groov Epic goes down, all the other ponds still run and they can still be seen through SCADA. So one Epic fails, the other pond systems keep running. And just like Renee was saying, it's future ready, it's scalable, you can copy and paste. So now that one system was created for one pond, and then it's just duplicated. So you can see all the ponds each have a Groov Epic, it's all duplicated, just like all the other ponds. And it all is connected to one ignition server through MQTT. Yeah, so these are the outcomes. So 2 hardware stacks were eliminated in this case study, the Siemens PLC and the Kepware server. It was all consolidated, one central edge device. 0 ponds were disrupted. So all the fish stayed alive. The Kepware server was eliminated. So simplified out their comms, reduced licensing costs and maintenance overhead. The Siemens PLC was removed. Epic takes over general automation and generator control via CodeSys, Modbus serial. Has full MQTT pipeline to ignition server, which is a modern scalable broker-based architecture. And single device handles all edge aggregation, control, and upstream comms. Brownfield ready and future-proof. Yeah, so that's pretty much the case study. And yeah, if you guys are interested in learning more, then yeah, reach out to me. I'll be very happy to go further into detail. But yeah, it was a really cool case study, and it just goes to show that whole system, like Renee was saying, it's completely duplicated, it's decentralized, and it doesn't have that critical point of failure like Kepware did. So if Kepware went down, the whole system went dark. But now they're future-proof and it's a lot more reliable than what it was before. Yeah, thank you guys.
Great. Yeah, that's great. I will actually, I had the privilege of being down. I've seen that site, going to see those pens, and those salmon pens are quite large. The infrastructure is quite large around the whole Tasmanian southern region, and they're all wirelessly connecting back to some sort of centralized office there back in Hobart. So, and like you said, they're all radio comms, so they do need uptime. And there's very few people now on those pens. It's all done by a remote operating center. So having high availability and being able to see without much loss is very important for that business. So so it's great that Opto 22 sits there in that space, providing what you mentioned, the connectivity and ability to remain active and minimize the issues around communications, and also the connectivity, which is quite key and quite crucial in those locations. It's a good case study. I will. Thank you.
Yeah, for sure. No, thanks, Ed. Thanks very much. I'll just share my screen now.
Do you have any other questions on that case study, Ed? Well, when you went, how far did you have to go off the coast? Did you go on the barge?
Yeah, well, actually, it's not far in. They've got a hatchery down there as well. Well, hatchery, they have the fish hatcheries, and then as the fish get larger, they put them into the pens in the estuary. So it's actually, if we get a chance when you're down here next, let's see if we can do something down there. But it's quite a interesting trip down to see all the salmon farms in that region. And like I said, those pens are quite large and they have a lot of fish, and actually have cameras that go down and watch and see how the fish are behaving. It's quite an interesting business.
I actually don't know.
Pascal.
I don't know if it's because of this case study, but I'm really interested in aquaponics. So
Yeah.
I want to use Opto and I want to use it Rio, and I want to completely automate it. I think it's just the nerd in me, but I think it'd be so cool to have it, at the back of my property and have it all automated. It'd be so cool. That'll be another case study if I ever get around to it.
Oh yeah, if you get a chance to go to Sal, it's well worth a trip.
Yeah, no, that's
I've been to floating salmon cages, but in South America, and it was quite a long ways away. And it was all same problem. You know, you're stuck in Industry 3.0, and now how do you get into Industry 4.0? And the answer in that case was Epic and Ignition again. Salmon farms we seem to do well. I mean, Tasmania, Australia, South America, Northern Europe, and I just wish more people ate salmon at this point. So, what's for dinner?
That's good.
So with that, excuse me.
I had it yesterday for breakfast. It was great.
There you go.
I love smoked salmon.
I actually buy to sell salmon pretty much. When I'm buying smoked salmon, I go to sell. It's a plug for to sell.
Yeah.
Can I have a
Do it right before lunch is a good time to have this case study. So with
Sure.
that, everyone, the goal of today was to show that Opto and Australia have been long friends, that the architecture hasn't really changed except for the communication side of it. And now with Opto 22 and Ignition and Australia are just better together. So we'll share this recording. And before we go, just if any parting words from Ed, I'll hand it off to your first for this webinar.
Oh, look, thanks, Renee. I think the Opto 22 product range is it's amazing. We definitely love the relationship we share with Opto, and the way that we both have the same passion around supporting industry, providing them with technology that helps them solve the problems that they have today and the ones we know coming tomorrow. So having that sort of technology built in and it's a really good relationship. So we thank you for this being part of the webinar.
Oh, you reminded me of, I should have put up the card that has all of our phone numbers and email addresses, because it was from the last webinar where we had a customer that bought an Opto 22 license that wasn't the Ignition license that they needed, but then because Inductive and Opto 22 work so well together, Ed was able to get them straightened out. So that was, that's just the kind of relationship that we have here. So, get the Opto from Binford and all the licenses. Call Ed so he can get you sorted out. So you can make sure to get you the right one. So Ivor, any parting words?
Yeah, no, I guess just, we're really proud that we're Australia's official Opto 22 distributor. We take that seriously. We hold local stock of all the Groov range of products, and we provide local sales, technical support, backed by Renee and Opto 22 in America. So yeah, that's really, really good. And yeah, we're right into COSYS and iLink. We're the, I guess, leading specialists there. And we've got broad capability across all major PLC brands. So yeah, please reach out if you have any questions or just want to chat, discover more. And yeah, I hope to hear from you guys soon. Thanks.
Yeah. Thanks, everyone. Have a great day. Enjoy your salmon lunch, everyone.
Thanks, Ed. Thanks, Renee. Bye.
Thanks, Ivor. Thanks, Renee.
Cheers.